Now, we've already seen that this risk-free rate minus the dividend rate has to be between U and D. But that does not mean that it's in the middle of U and D. And in particular, if you just multiply U and D and go back to that definition, if you multiply them, the sigmas cancel out, and you see that U times D is e to the r minus delta. In other words, when you go 2 steps in a lattice, up and down, or down and up, you end up at a position which could be greater than 1, equal to 1, or less than 1. Most trees tend to be convex because in many applications R is bigger than delta. If R is bigger than delta, this exponent is positive, and that means that UD will be bigger than 1. We'll also see trees, however, where R can be equal to delta or R can be less than delta, and in fact the tree will be concave. So what do I mean by that? I mean this, that typically people think of a tree as being, in a sense, rectangular. And it's natural to think that these midpoints, are horizontal. So this is the point up and then down. So this is SUD. And the point that I made in the earlier slide is that if you go up and then down and up, this point is going to be typically in many trees higher than that point. That the tree will actually proceed in a convex manner and so forth. So that every 2 steps in the tree, the value of the stock is going up according to UN dn. So you have n ups and n's downs, and you end up with e to the n times r minus delta h. So it's going up. Similarly, when this is the case when r is bigger than delta, when the risk-free rate is greater than the dividend rate, the tree will drift up, and correspondingly, when the dividend rate, it'll drift down. If r is equal to delta, then the tree will look like a rectangular tree, and it'll simply, the value of the price will simply be the same at every second interval. Will be the same every 2 steps. So in order to price an option, what do we need to know? We need a stock price and a strike price. We also need a standard deviation of returns, the sigma for our U and D function, a dividend yield delta, and a risk-free rate R. If we use the risk-free rate in sigma, we can approximate the future distribution of stock prices by creating a binomial tree. If we just play out that binomial tree period to period, we can get a distribution of prices. And once we have a binomial tree, we'll be able to price the option using the earlier formula. Once we have the binomial tree, it'll be possible to price the option using the earlier equation if it's a 1-period option, and in the next module and the following one, we'll see how to generalize this pricing procedure to binomial lattices that have multiple steps.